For problem 5.1.7, we're given a series of reactions to obtain magnesium from salt water, and we need to write the balanced chemical equations for each step in the process. This is very similar to problem 4 in this section. So for part A, it's described that we begin with the decomposition of calcium carbonate, which is solid, according to our description, from seashells to form calcium oxide, solid, and gaseous carbon dioxide. So the first step is to use the words describing the reaction to write the chemical equation for this reaction. Now we have to check and see if it is balanced. So I'm going to make a list of all of the compounds I have on both sides of the equation. And if you watched the video for problem 4 in this unit, you'll remember I said that we can keep polyatomic ions together if they stay together on both sides of the equation. So we cannot keep the carbonate together when we're counting in this problem because there is no carbonate on the right-hand side of the equation. It's broken apart into carbon and oxygen. So we're going to go ahead and count the number of atoms we have of each compound or element. So I have 1 calcium, 1 carbon, 3 oxygens, 1 calcium, 1 carbon, 3 oxygens. This equation is already balanced as written, so we don't need to do anything else, and we can move on to part B, the next step in the reaction, where we form, so it's giving us the product first, calcium hydroxide. Remember, hydroxide has a charge of -1, and calcium, coming from the second column of the periodic table, has a charge of +2, so I'm going to need 2 hydroxides for every calcium in order to balance the charges, and that is a solid. It's the only product from the reaction of solid calcium oxide and liquid water. So once again, we're going to make our list of compounds on both sides, and since the OH is broken down on the left-hand side this time, oxygen appears by itself, we're going to have to list oxygen and hydrogen separately from each other. So when I count, I have 1 calcium, 2 oxygens, and 2 hydrogens, and when I come over to the right-hand side, I have 1 calcium, 2 oxygens, because my subscript distributes, and 2 hydrogens. So this equation, like the last one, is already balanced. For part C, the third step of our reaction says that solid calcium hydroxide, which we produced in part B, is added to the seawater where it reacts with dissolved magnesium chloride. Now the dissolved indicates here that it is aqueous, and since it's aqueous, that is taking care of the water that's there but not reacting with anything. It didn't say it reacted with the seawater, it reacts with the magnesium chloride dissolved in the seawater, an aqueous solution of magnesium chloride. And that yields, so there's our arrow, solid magnesium hydroxide, just like the calcium hydroxide. Magnesium's in the second column of the periodic table, so I'm going to need 2 hydroxides to balance my charge. And aqueous calcium chloride. Almost ran out of room. So once again, I'm going to go and I'm going to count up everything on both sides of the equation. Here, my OH stays together on both sides, so I can count it as one thing if I want to. And I like to do it that way. It makes it easier for me. So I'm going to. You would get the same answer if you counted the oxygens and the hydrogens separately. I have 1 calcium, 2 hydroxides, 1 magnesium, and 2 chlorines. And on the right-hand side, I have 1 calcium, 2 hydroxides, 1 magnesium, and 2 chlorines. Once again, like the previous two, I see that this is already balanced. So now I can move on to the next step, which is part D, where the solid magnesium hydroxide is added to a hydrochloric acid solution. Solution is another key word where it tells us that it's an aqueous solution, not a liquid, and that produces dissolved magnesium chloride, dissolved, another key word to clue us into the fact that it is aqueous, and liquid water. Once again, I'm not going to fall into the trap that they've all been balanced before this, so they must all be balanced. I'm going to count and make sure, and you might remember if you watched the video for problem number 4, we can think of water as H bonded to OH because that's technically what happens, as we'll get into when we talk about acids and bases, but for now we can just count it that way and make our life a little bit easier. So I make my list. I have 1 magnesium, 2 hydroxides, 1 hydrogen, and 1 chlorine on the left-hand side, 1 magnesium, 1 hydroxide, 1 hydrogen. Don't fall into the trap if you're going to count it that way that I just did. We only have 1 hydrogen and 2 chlorines. So it's a good thing I counted and didn't fall into the trap of the previous 3 for balanced, so these must be also, because it's not. So I'm going to go in and I'm going to first balance my OHs by putting a 2 in front of water. That gives me 2 hydroxides and 2 hydrogens on the right-hand side now. So now I need to balance my chlorines, and in the act of balancing my chlorines on the left-hand side, I've also balanced my hydrogens. So now I have 1 magnesium on both sides and 2 each of the hydroxides, the hydrogens, and the chlorines on both sides, so now this equation is balanced. The final step in this process, part E, says that the magnesium chloride, which has now solidified because we melt it and electrolyze it, yields liquid magnesium metal and diatomic chlorine gas. Once again, we're going to count really quickly to make sure that this equation is balanced. You probably don't even need to make the list and count, you can just do it visually, but there's 1 magnesium and 2 chlorines on both sides, so this equation is balanced.